Dear students, welcome to this session. In this session, we are going to talk about the association rule mining. This is one of the unsupervised machine learning technique, similar to the clustering analysis. Association rule is also a unsupervised learning, meaning like we don't have any target variable. We will not have any kind of a target values known prior to the exposure of the data or the training of the model. In this particular association rule mining, so what it is going to do is like it is going to find if there is any hidden kind of a association between the items or any kind of events, and if there is a association when it is mining the data, we will set a certain support level and the a confidence level, because there will be many relationship. We don't want to get all the association rules which may not be having a business impact or useful to the business or useful to the organization for which we are doing this particular analysis. So association rule is very important. It can find some important association, especially for the e-commerce businesses. So when we mine the all the data, that is the whatever the data we are getting from the point of sales systems, that is also called as a market basket. From market basket, we will come to know what kind of products are being purchased by the customers, various ranges of the customer age group or their different locations, demographic changes would be there. So based on all this, we can have a huge amount of data. On that data, we can do the mining to find any association rules. If there are any useful association rules with a certain support level and the confidence level, those can be very useful for a lot of things, like we can do the cross selling, we can do the upselling, and we suppose in designing the retail store, we can use that particular information. If we know two or three items, they are getting sold together most frequently, then maybe you can place those three items together, so that whenever the customer is coming there is a high probability that he will pick the three items. Or the other way of putting that is like you can put those three items in three different places, so that the customer will be looking, he will be moving from one item to the another item, and during which he will be exposed to many other items, and probably he might buy those products. So that way association rule will help. That is one example. Another example is regarding the patient diagnosis. If we can find a kind of a relationship between the disease and the diagnosis, maybe that will help in using that particular diagnosis whenever we have a particular disease. So the association rule mining, it's a very popular, as I told you, unsupervised learning. It tries to find out the relation between the items or the variables or the events, whatever you want to call. It will try to find the relationship between the each item. All data used in this technique is categorical. There is no dependent variable. As I told you before, we will not be having any like a target or the dependent variable, and all values are categorical. So categorical means it will be having some kind of a category. For example, for the category is like a size, small, medium, and large. So those kind of variables are called as a categorical variables. It uses machine learning algorithm. The fascinating relationship between the sales of diapers and beers is how it is often explained in a popular literature. In many of the literature, we find this very relationship, very important relationship between these two items, that was due to the analysis of the market basket. That is how this relation was established, and that relation was utilized. This technique accepts the input from the point of sale transaction data. So I told you, any input, that is the point of sales, that is the input, and on that input, the algorithms will be worked to find the association rules. The output produced is the description of the most frequent affinities among the items. So it will find the most frequent items that are bought by the customer. So it will give that affinity. Example, customer who bought flight tickets and hotel reservation also bought the rental car. Okay, more than 60% of the time. So this is one association. A person who is buying flight ticket as well as he is doing the hotel reservation, there is a 60% chance that he will also buy the rental car. This is the one example done by the Netflix, and this example is very very effective. And this particular Netflix example, it has increased its viewership, because kind of a recommendation it gives for the viewers, what kind of a videos they can watch. This is very highly successful. Maybe this the success of this data mining is because of the kind of a people who likes to watch certain kind of movies or documentaries or any kind of videos. They have a quite similarity. A person having a affection towards a certain kind of a movie will also like certain other kind of a movie. So if a third person is watching the first movie, the second movie can be recommended to that person. There is a very high chance that the person will be watching that particular video. He might be liking that video. He will be giving the higher ratings. That is how the Netflix can increase their viewership. They have a algorithm called as a cine match. Okay, that will mine through all the users data, what are the historical data the users have been frequently watching, and it tries to match with the other people. So it is trying to find the association, a person and the kind of a videos, and that is how it will do the recommendation. The company estimate that's a whopping 75% of the viewers' activity was driven by the recommendation. So you can see that many viewers, they rely highly on the recommendation. So their estimates suggest that 75% people are going through those recommendations, because the reason being, yeah, the whenever you watch certain thing, if it automatically can get the related videos, there is a very high chance that that particular video will be liked by the viewer, and he will continue to go for the recommendations rather than he going and searching for the particular video. And this was very very popular. And on mining process, whether algorithms are depends on mining process. So no, it is like other way, Alphan. Algorithms, for example, we will see one algorithm today for finding the frequent items. We create the algorithms to do certain thing. So here activity is what, in this particular machine learning thing, we want to find the association. Okay, this is association rule we are trying to find. So to find that association rule, what kind of algorithms can be implemented? For example, we have a classification problem. We want to classify the data. Depending upon, there are many algorithms are available. We have simple logistic regression that can be used for the classification or the prediction, or we can have a most sophisticated artificial neural network algorithm that can be used. So uh, you are going to use, there are many available algorithm, and you will try to see which one will best suit particular kind of a problem you are trying to solve. So every business is different. In some data set, the logistic regression might give the highest accuracy, and in some cases the artificial neural network might give. So it depends. So it's always like it's a trial and error. You will keep on looking for different algorithms, you will apply to it, then you will see which one gives the better results. Is that your question, Alfan? Did I answer your question?
Yes, sir.
Yeah. So in Netflix example, they also conducted one a contest to challenge their algorithm. Then that challenge, they gave like a $1 million prize for that. Many people work to challenge that particular algorithm, whatever the Cinematch algorithm that Netflix has. Many tried to beat that Cinematch. They wanted to have more accuracy or higher, better recommendations than this Cinematch. And one team who consisted of 7 people, after 3 years of work, they developed an algorithm which was much sophisticated than Cinematch, and its recommendation was much better. And actually, they won the prize of $1 million. So you have to come up with the algorithms. There are existing algorithms, and also you can build new algorithms on top of that. Okay, Netflix example. This searches the Cinematch database for people who have rated the same movie. For example, The Return of the JD. So some people have looked into this. Determines which of those people have also rated the second movie, such as The Matrix. So this is the first movie they have rated, and the second movie they have rated. Calculate the statistical likelihood that people who liked Return of the JD also the matrix. So that is how you can find the association. Then you can start recommending based on their ratings. Continue this process to establish a pattern of correlation between the subscribers rating of many different films. So that is how we can bring in that association, and using that association we can do the recommendations. The business applications of association rules. Association rules can be applied in many areas. For example, it can be applied in the field of medicine. The most relevant would be in the field of the marketing. Okay, then sales. Those are the domains. In business environment, a pattern or a knowledge can be used for many purposes. In sales and marketing, it is used for the cross marketing and cross selling, catalog design, e-commerce site design, online advertising, optimization, product pricing, sales or promotion configuration. So these are the different areas where we can use the association rule. And analysis, this analysis can suggest not to put one item on the sale at a time, and instead create a bundle of products promoted as a package. So this might give some kind of a information where you can bundle instead of selling single item. Many of the deals you must have seen, if you go to any of the e-commerce websites or the stores, you will find they will have a bundle of the items. So that bundle will be comprising of many different things. Some of them are very popular, and some are not popular. In order to make the sales for the very not popular items, you can bundle, and that package will get sold. Okay. In retail environment, it can be used to store design. I mentioned earlier, you can use it for the store design. You can keep the frequently bought items together, so that the customer can pick all of them, or you can keep them at different places, so that while customer looking for those items, he will get a chance to look into other items as well. So in the field of medicine, this technique can be used for the relationship between the symptoms and the illness. Okay, diagnosis and patient characteristics or treatments, genes and their functions. So there are many things where we can find the association rules. Representing the association rule. So you can see a generic association rule represented between the set X and Y. Here X implies Y, and this S percent is the support, and this is the confidence. And here X and Y are what? It can be product or any kind of a services. So X is one left hand side, you can say product or a service. This is the right hand side product. So the rule is X implies Y. Means, for example, if person buys milk, he will also buy bread. So X is a milk, Y is a bread. And what is the support percentage, and what is the confidence percentage? S support how often X and Y go together in the data set. So how often these both, suppose if it is a bread, milk and bread, how often they go together, that is the determined by the support. Okay, so it is the probability of X and Y together. So X union Y. Then what is confidence? How often Y is found given X. So if given X, then how often we can find Y. That is also a probability of Y given X. And we have a formula. Using that formula, we can calculate the this particular probability. We have an example here: hotel booking and flight booking. If this happens together, hotel booking and flight booking implies rental car. So this is the rule, means a person booking a hotel as well as a flight, there is a high chance he will also have a rental car. And what is the support for this? 30% and 60% is the confidence. And P of X is the mathematical representation of the probability or a chance of X occurring in the data set. For if I say X is milk, so what is the probability of milk being bought by the users? Like if there are 100 transactions, and let us say 50 times the milk is bought, means in 50 transaction milk is present, then the probability P of X is 50 by 100, that is 0.5. This is one computational example we have. Okay, we have 1000 transactions, and there are 300 occurrences of X is just, you can assume, as a milk. So there are 300 occurrences of milk, and 150 occurrences of X comma Y, that is milk and bread, just for the example. Out of these 1000, 300 times milk has been bought, and 150 times milk and bread together has been bought. If I make a rule, okay, X implies Y, means milk implies bread, then the support for that would be P X union Y, that is 150 times, that is the time X and Y, they are bought together, they are present together, 150 divided by the total number of transactions. 150 divided by 1000, the support is 15%. And if you want to calculate the confidence for this rule, P of Y given X, that is calculated as P of X union Y divided by P of X. So that means out of the total occurrences for the product P of X, this is the total probability of the occurrences of the milk, and these are the together milk and bread. So milk and bread together, it is 150 divided by, that is just the milk, P of X is 300, that comes as 50%, that is the confidence. So always whenever we are finding the association rule, we are going to filter by the support and the confidence. We want to set some support level. Let us say we want to set support level of 30% and confidence of 40%. If the rule is having support of greater than or equal to 30% and the confidence is greater than equal to 40%, then only we will select those association rules for further processing. Not all associations rules are interesting and useful, only those that are strong rules, and also those that occur frequently. So as I said, there are many rules that can come out of big data. Uh, all rules may not be useful. So that is why we have to set a certain level for the support and the confidence. In association rule mining, the goal is to find all the rules that satisfy the user specified minimum support. I told you you have to set some minimum support, and minimum confidence, and whichever rules they are passing that particular criteria, those will be selected for the further processing. So there are a large number of algorithms that are available for generating such algorithm. The most important algorithms are this. We have a priori. We are going to see one example of this particular algorithm. Then we have eclat, then FP growth, okay, along with various derivative and hybrid of these three. So there are many algorithms which will help us to get those particular association rules. All algorithms help identify the frequent item sets, which are then converted into association rules. So using these algorithms, we are going to find frequent item set. What is the meaning of the frequent item set? Frequent item set is the set consisting of the items which are bought frequently together. Okay, that is the frequent item set. First one is the a priori algorithm. This algorithm is very, very popular in case of association rule mining. The objective is to find subset that are common to at least a minimum number of the item sets. That's the goal. The frequent item set is item set whose support is greater than equal to minimum support threshold. Whatever the minimum threshold we are setting, that frequent item set will be having support greater than particular threshold. A priori property is a downward closure property. What is the meaning of that is, suppose if you get a frequent set as A, B, C, D is the frequent item set which is above the threshold of the support that has been set, then this A comma B comma C comma D is the frequent item set. If this is the frequent item set, then the subset of this, for example, subset of this is A comma B comma C or B comma D, any of this combination subset is also a frequent item set. It uses a bottom up approach. So you can see we start from the bottom and we goes to the highest level of the frequent item set. The size of the frequent subset is gradually increased from one item subset to two item subsets, then three items, and so on. So initially we begin with the one item, then we add two items. We will see the example. In the example, it is very clear. Then two items, three items, four items, until and unless we are getting the item set which is having support and confidence more than what is the threshold that we have set, we should keep on increasing the number of items. Groups of candidates at each level are tested against the data for a minimum support. So we are going to check for the minimum support. So this is the data we have. This is the transaction data. There are 12 records are there. First transaction means this is the first sale. A person has bought milk, egg, bread, and butter. So there are, I think, six items are there altogether. Six different items are there, and we have 12 transactions. In the second transaction, a person has what? Milk, butter, egg, okay, ketchup. The objective of this analysis is to find the any kind of a association or the affinities between these products. See, this is the data. As of now, I can see just the data. I don't see anything beyond that. Here our objective is to find if there is any close association between the any of the these products. The association rule exercise, we are going to set the support level 33% and confidence level 50%. So we are going to pick those items which are having higher support level greater than or equal to 33%, confidence greater than equal to 50%. That means we have decided to consider rules from only those items that occur at least 33% of the time in the total set of transaction. The confidence level means that within those item set, the rules of the form X implies Y. This is the kind of a rule, that is milk implies bread. Okay, so should be such that should have at least 50% chance of Y occurring based on the X occurring. So first we are going to select only one item out of that list. So whatever the items we have, we are going to check only one item. We are going to say there are six different items, right? we are going to list 6 items, and we will count in how many transactions they have been bought. For example, milk. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 out of these 12 transactions has a milk. So that is how you are going to write one item set and frequency. Milk 9, bread 10, butter 10, egg 3, ketchup 3, cookies 5, so on. So this is the first level of our first step, where we use the only one item. Then we will find the confidence level and the uh, support level. At every point, there is an opportunity to select the item of interest, and thus further analysis. Other items that occur very frequently may be removed. Now, if you see, if item set that occurs 4 or more times, 4 means what? We have set the support as 33%. 33% is what? 4 out of 12. 4 by 12 is nothing but 33%. If item is not bought at least 4 times, its support level is less than 33%. So we are going to leave those items. In this particular example, you can see we have egg only bought 3 times. What would be the support for this? 3 by 12. So that is less than 33%. Similarly, ketchup. We are going to select only 4 items: milk, bread, butter, and cookies. Next step is we are going to consider 2 item sets instead of considering one, 2 item set. If these items are bought together, we are going to count that transaction. For example, first one is milk bread. We go back to the original data. You can see milk bread one transaction. Here milk bread second, milk bread third, milk bread 4, then milk bread 5, milk bread 6. Maybe we missed one. So we have 7. There are 7 transactions which has milk and bread together. Similarly, we will find other items. What are the possibilities I can have? I can have milk bread, milk butter, milk cookies. Those are the first 3 records: milk bread, milk butter, milk cookies. And next, you are going to consider bread butter, bread cookies. This is, sorry, bread butter, bread cookies, and the last one is butter cookies. Butter cookies, and you are going to find in how many transactions these items are together, and you are going to list. And here also same thing we are going to do. The minimum support level is 33%. If frequency is 3, then those items will not be considered. What we will be left with: milk bread, milk butter, bread butter, and bread cookies. Now we are going to increase it to the 3 items: milk, bread, butter. So from here you can see milk, bread, butter. So possible combination, 3 combination: milk, bread, butter, milk, bread, cookies, then bread, butter, cookies. And you are going to find how many times these 3 items are bought together, and you are going to write the frequency. Now you can see milk, bread, butter, we have 6. Milk bread cookies only one time, bread butter cookies only one time. So this record and this item set, they will not will not satisfy the minimum support level of 33%. So we are going to choose only milk bread butter. So milk bread butter, and that is the only item we are going to select. And there is no possibility of having a four item. Okay, so we will stop it. If there are more items, you can continue with finding the highest item set. That will, as much as possible, you have to keep on increasing. Once all the products are done, then that would be the most frequent item set. In our case, this is the 3 item set is the most frequent item set. Next, now we are going to create the association rules from the frequent item set. The most interesting and complex rules at higher size item set start top down with the most frequent items of higher size numbers. Association rules are created that meet a support level of 33%, greater than 33%, confidence greater than 50%. Now we are going to create the association rule which will follow these minimum criteria. The highest level item set that meets the support requirement is a 3 item set. The following item set has a support level of 50%, that is 6 out of 12. So uh, you can see here 6 out of 12 transaction. 6 by 12 is nothing but a 50%. So it has a 50% support. The item set could lead to multiple candidate association rules. Now we have item set. It will lead us to a many association rule. We have to pick those association rules which will have a minimum support and the confidence that has been set as the threshold. We start with the following rule. So what are the items we have? Milk, bread, and butter. We start with the rule, bread, butter implies milk. So this is my x and this is y. Left hand side is x, this is y. Then I'm going to find the what is the support and the confidence of this. So there are 12 transactions. Out of those 12 transactions, x is what? Bread, butter together. It occurs 9 times. So you have to go back a little bit. I will show you once. Uh, Bread, butter. You can see 9. So you have to keep on going back to the previous tables and getting the count. X is bread butter 9 times, and x comma y, that is x and y together, that is x is bread butter and milk together how many times? 6 times, previous slide. So what is the support level for the rule? 6 out of 12 times, that is 50% is the support level. Then what is the confidence? The 6, this 6 divided by 9. Okay, 6 by 9, 67%. So this is greater than 33%, this is greater than 50%. We can accept this as a valid association rule. So bread comma butter implies milk, inside the curly braces. Support is 50%, confidence is 67%. So this could be a association rule. Next, in the same pattern, we can have another. Milk comma bread implies butter. Here also 12 records are there. Milk and bread, they are bought together 7 times. All the three are bought 6 times. So what is the support level? 6 out of 12, 50%. And what is the confidence level? 6 divided by 7, that is 84%. So that is how this is also a second valid association rule. That is milk, bread implies butter. Means if a person is buying milk and bread, definitely he will buy the butter. So this is the support and the confidence level for that particular rule. One more rule, milk comma butter implies bread. So we have three products. We are taking the combination as a x. In this case, milk and butter, they occurs 7 times. They are bought together 7 times, and all the three 6 times. And what was the support level? 6 out of 12, that is 50%, and confidence level 6 out of 7, that is 84%. And this is also an valid rule. Thus, there were only three possible rules at the 3 item set. We can have only three rules. Now we can go to the 1 item level, 2 item level, right? We can find various rules. We can find so many rules out of it. For example, we have here 1 item level. Milk implies bread. How many times? Now X is milk, bread is Y. Total 12 transaction. Milk occurs 9 times. Milk and bread together they occur 7 times. Now how to find the support? The support would be 7 times these are bought together out of 12, that is 58%, and confidence is 7 divided by 9, that is 78%. So this is also a valid rule. Milk implies bread, 58% of support and 77% of confidence. Many such rules could be derived if needed. So as we see, like we can go to 2 item set, then create rules, 1 item set, create rules. Many rules can be created. Not all such associations rules are interesting. Okay, not all may not yield some kind of a useful thing for the any kind of a alterations. The client may be interested in only the top few rules that they want to implement, right? You cannot implement all the rules. Whatever is the top few rules that it can be implemented, and that is how that will help the business. Implementing every rule in the business will require cost and effort, because suppose because of this rule you want to redesign how the your store is, that again it incurs a cost. So we don't want to implement all, but we want it is better to implement only top few rules and see what results we are getting, and slowly implement the other rules as well. Conclusion: association rules help discover affinities between products in transactions. We saw it gets a association or the affinity between the products. It helps make cross-selling recommendations much more targeted and effective. A priori technique is the most popular technique, and it is the machine learning technique.